Galaxies look stationary. So why do scientists say that they rotate? That's a very good question. So, according to what we know about galaxies, or according to what scientists say about galaxies, a galaxy, a typical galaxy like the Milky Way, for example, would complete one full rotation in about 1 billion years or so. Maybe some are faster, maybe some are slower, but something like that, right? So that's a very slow rate of rotation. So how do we know that galaxies are rotating? That's a very good question. I'm sure your teachers never answered this question. I'm sure that you did not even get to ask this question because you can't ask questions in school. So how do we know that galaxies rotate? There is something in physics called redshift and blue shift. You must have heard of the Doppler effect. The Doppler effect is when you are standing stationary and a train is coming towards you at a high speed, and the train's whistle or siren seems shrill when the train is coming towards you. But the moment it passes you, the pitch of the whistle changes, it becomes lower in pitch. So that's an example of the Doppler effect, because when the train is coming towards you, the frequency of the waves is compressed, the wavelengths are compressed, and that's why the sound seems higher. And when the train is receding away from you, that's when the wavelengths of the sound are elongated, and that's why it sounds lower in frequency. So the same thing happens with light. So there is a Doppler effect in light as well. There's redshift and blue shift. When a luminous object is receding away from you, its light waves, the wavelength of the light is elongated, and that's why it appears redder than if it was not moving away from you. And if it's coming towards you, then the light is blue shifted towards the blue end of the spectrum, because the wavelengths are compressed. So there's red shift and there's blue shift. So if you look at a galaxy, if you observe one end, then you will find that the light is red shifted. So for example, you have certain spectral lines. For example, sodium and other elements that produce very specific light. They produce light of very specific wavelengths. And when you observe those wavelengths from a distant galaxy, you will find that at one end of the galaxy, those wavelengths are red shifted, which means that that end of the galaxy is moving away from you. And on the other hand of the galaxy, on the other side of the galaxy, you will find that the same wavelengths are blue shifted, which means that they are moving towards you. So the galaxy, one side of the galaxy is moving away from you, the other side of the galaxy is moving towards you. This is clear from the red shift and blue shift that you see from the two opposite ends of the galaxy. And that indicates that the galaxy is rotating, right? So that's one way, one excellent way of determining that whether a galaxy is rotating or not. And we find that all galaxies are rotating, and depending on various measurements, we can actually determine to a good extent the rate at which it is rotating. How fast is it rotating? And that's how we get the galaxy rotation curves, those graphs which actually showed us that there is missing matter out there. And that's how dark matter came into the picture. Now, what's the other way that we know that galaxies are rotating? Well, most galaxies are spiral in shape. How do you get a spiral shape? Let me show you how you can get a spiral shape. Let me just play a 5-second video for you. Hang on. So that is a ball that is wet and it's been spun like that. And you can see the spiral shape that it's creating. The water is ejected in a spiral shape. So that's precisely what we see in galaxies. The video I just showed you is that of a ball on Earth. It's a very slow motion video, high frame rate, but that's the same sort of shape that you see in galaxies. So the spirals are at a 90-degree angle from the axis of rotation. So that's another way that we know that galaxies are rotating. And that's how we know for a fact, based on this observational evidence, on various different kinds of observational evidence, that galaxies are indeed rotating. We know they are rotating. We can actually measure the rate of rotation, even though we can't see a galaxy do a full rotation, because it would take 1 billion years or hundreds of millions of years, and we don't live that long, and yet we're able to tell that they rotate. So this is how it's done.